Uptake, and I come from Department of Environmental Affairs, NRM. There's just a few announcements before we get started. There'll be a group photo just before lunch at the back next to the swimming pool. So please, if we can all proceed from here before we have lunch to have that group photo taken. And just an announcement from Ian MacDonald. Anybody who would like a copy of his presentation, that is available to everybody in the room. So if we can start, our first presenter is Jackie Hill, and she'll be doing a presentation on the preferential nitrogen uptake in duckweed and the effects of the potential nitrogen-fixing symbiosis on nutrient acquisition. Thanks, Jackie.
Thanks very much. Good morning, guys. I'm going to talk to you a little bit today about some of the work that I do. My name is Jackie. I work at Rhodes University in the Biological Control Research Group. The majority of my research actually looks at nutrient loading in aquatic ecosystems and trying to look at the knock-on effects of eutrophication in terms of trophic interactions. So I'm going to talk about preferential nitrogen uptake in Spirodela and the effects of a potential nitrogen-fixing symbiosis, and I'll give you the reasons for that in a minute. I'm sure you're wondering why I'm talking about duckweed. So as we all know, eutrophication is one of the primary drivers of invasion. And it's coming to light more and more these days that nutrient loading may actually dictate the success or failure of a biological control application. And this has been proven quite succinctly for water hyacinth and numerous other floating aquatic macrophytes. Unfortunately, at the moment, the tools we have at our disposal to assess eutrophication fall into one of two categories. One, they're either water quality measurements, so they're not time integrated and they're very difficult to assess nitrogen dynamics in the system, or they're more representative and quantifiable, things like the SAS5 technique, which allows us to determine whether a system is impacted or not. Unfortunately, the SAS5 technique, indices of biotic integrity, they only allow us to assess ecosystem damage after it's happened. So really what we need are new tools that allow us to describe eutrophication before the damage actually takes place, but also in a time-integrated fashion. There's been a lot of work in recent years where we can use stable isotope analysis to do this. Stable isotope values are found throughout nature, and they're very useful indicators of eutrophication. And we're trying to apply this in South African systems. So to give you an idea of what I'm talking about, these are two graphs that were reproduced from a paper by Costanzo et al., 2004. And I hope you can see them here. The writing is a bit small. But essentially what they did was they took plants and they incubated them in a laboratory. Then they took them out and they deployed them in Moreton Bay in Australia. And they let them grow within the bay for about a month. And then they went back and they took samples of the plants and looked at the stable isotope values of nitrogen. And what you can see very clearly is wherever there are sewage inputs or anthropogenic inputs of nitrogen into the system, you get really heavily enriched isotope values. And those are the black values on that left graph there in February of 1998. And the further out the pollution radiates, it disperses, and you get a much more depleted stable isotope signature. So if we use this technique, it allows us to really map hotspots of pollution, which is very important in terms of biological control, because we need to understand the dynamics of the system, because invasive species are usually just a symptom of the problem. So what that allowed them to do was to map out where the pollution was coming in and how far it was radiating out into the bay. And 3 years later, they managed to get a handle on the pollution, and you can see from the second graph, in 2001, the amount of pollution that's been inputted into Moreton Bay is drastically reduced because we have much more depleted stable isotope signatures. So we're hoping to try and apply this in a South African context because we have a lot of constraints on our fresh water. So Sven Kaler, Martin Hale, and myself decided to try this and set up sort of a baseline series of studies to try and apply this in the freshwaters around the Eastern Cape. And we wanted to choose a plant that we could transport just about anywhere. It was very fast growing and was very easy to manipulate. So about 2 years ago, we finished doing the laboratory studies looking at Spirodela, which is a duckweed that's ubiquitous just about everywhere. And what we discovered was Spirodela stable isotope signatures of nitrogen very clearly distinguished between nitrates and fertilizers and manure or sewage. So plants that are grown in fertilizer